As soon as Google realizes that I have pressed the recording button. Oh man. There we go. Just when I was about to say, can someone else do this? All right. And presenting. Let's see if I can get this to work just with a window. Maybe not. Okay. Entire screen it is. Are you all able to see my screen now?
Mm-hmm.
Excellent. Okay.
Yep.
Hello, everyone. Today's talk is about callables in Python. So, what are callables? Callables are reusable subsections of code which perform a specific task. That's also just a fancy way of saying function. But technically, in Python, there are more functions are just one type of callable. There are actually several different types, and we'll go over several of them in this talk. So start at the beginning. Functions, you've probably already seen functions. This is the syntax of a function. It's very simple. There's the def keyword, which introduces a function, the function's name, and then a list of parameters, in this case, number 1 and number 2. The function body, which does something with the parameters that it was given. In this case, it's adding number 1 and number 2 together. And then usually the function will return some data, so it returns the result to the caller. So that's a very simple function. You've all seen something like that before. Why do we need functions? This is something that maybe you had some answer given to you when you took a class, or maybe you just had to kind of work through it on your own and figure out, well, why do we need these functions? I see that everyone's using them. What are the patterns for when they use them and when they don't? Well, one of the very common answers to why we need functions is to reuse our work. So if I have some code somewhere in my program and it does something, like let's say it has a loop that reads input from a file and then it checks each line of the file to make sure they're all ASCII characters, and then if so, then it passes the information on, and if not, then it filters them out of the data stream. Let's say that I'm doing that in 5 different places in my program. If I just copy and paste that code around to 5 different places, then I'm making more work for myself. I've got to look it up every time I need it in a new place, copy it, paste it. Maybe I'm pasting it wrong. I leave out one of the lines. Maybe if I find a bug and I fix it in one place, oh no, now where in my code are those other 5 places I have to go, and I have to look for them, and I have to fix them in more places. So by using a function, all of that code is put into one place inside of the function, and then when I need it, I just call the function. And that way, I'm not having these problems of copying and pasting the code where I have to look all over my code for the same thing in the different places and fix it everywhere. I just look in the function, and that's the one place that I have to fix it. So that's great. All by itself, that's a good thing. Functions also allow us to organize our code. So what do I mean by this? Let's say that you're writing a program and it gets larger and larger and larger because it's doing more and more and more and more things. Pretty soon you have this 3,000 line file that is your program. This is going to be hard to read, hard to debug. It's time to organize it into something that's easier to maintain. And functions allow you to do that. Because what you do is you take a portion of code, say that file reading that we talked about earlier, you pull it out into a function. And now instead of having, 10,000 lines in a single file, in a single, function, now you have, 10 less because you move that into a function. Then you look through your code and you say, oh, here's another logical section. This is something that deals with asking a web server for information and getting that data from it. You pull that out into a function. You find other logical pieces of code and pull them out into other functions. And at the end of it, you have one function that's 20 lines long, and then that calls other functions, which are also 20 lines long or so, and they call other functions and other functions, other functions. And so your code becomes more organized. You can see it more as like a hierarchy, rather than as just one long recipe that goes from beginning to end that you have to swallow all at the same time. As part of organizing our code, these functions are really allowing us to abstract the problem, which means that, okay, when I look at that top level function, when it was 3,000 lines long, I kind of had to read through it line by line and see what each line was doing, how it might affect lines further down in the function. And I would have to understand a lot of stuff that probably in the end, it turned out I didn't need to understand that. I only really needed to know about this one section here, halfway down the function, to understand what was going wrong. By splitting it out into separate functions, we're abstracting that. We're saying, instead of knowing, for instance, oh, this is a section of code which is contacting a web server and getting some data from it and parsing it and returning it as like a Python dictionary, instead of having to know all of that stuff, by putting it in a function and naming it like get data from web server, when I see the function call in my main function, I see, get data from web server, server URL. Oh, and it's being saved into a data variable. I don't need to know how that function is implemented. Just from the function's name, I know what it's doing. So this allows me to say, oh, is this where I'm seeing a bug? No, it's probably not here. And I don't have to worry about all the code that's being implemented. I can just skip that and say, okay, I know what it's supposed to do, and keep on going and keep on reading. So it allows me to, abstract the problem. I'm not dealing with the implementation of every single bit of the code as I read through it to be able to debug something, only the parts that I need to. Functions, procedures, and methods. You've probably heard these names. They're all names for the same thing. They're just slightly different. Functions are kind of a generic name. They're interchangeable with callables, but there is, this concept of a pure function. And once in a while, you'll hear someone talk about functions in this pure function sense. Pure functions take input and return output. So if you look at add numbers again, its input is number 1 and number 2. It does something with number 1 and number 2, and then it returns the answer of what number 1 plus number 2 is. This is dealing with input and output. It doesn't deal with any global state of any sort. And what do I mean by that? Well, with procedures, unlike functions, if you call something a procedure, you're probably pointing out that it can use or modify global state. So in this print message function, which I have here, you can see it's doing two things. It's reading from os.environment user, and that's not being passed in via a function parameter. Instead, it's this global variable in the Python environment, and someone else in the global environment could set user, and they could set user to something different, and that will affect what print message is going to print, even if the function parameters are the same. So if I passed in hello as the message, and I'm running this myself, OS environment user will say, oh, this is Toshio, so it'll say Toshio said hello. But if someone else changes that environment variable user to Cookie Monster, print message will suddenly start printing Cookie Monster said hello. And that's a change that's happening without changing the function parameter. So that means that this is no longer a pure function, but a procedure. The other thing that it's doing is it's modifying global state. And you might look at it and say, well, I don't see it, setting an environment variable. I don't see it setting a global variable. What is it doing that's, modifying global state? Well, the print is actually modifying global state because the terminal is a shared global state, right? When I call print inside of this print message, it prints to the terminal. But the state of the terminal is going to be different depending on if I called print message once or twice, or if I called a different function that also prints to the screen, or if I cleared the screen before using it, and so forth. So the terminal is the global state in this case, and it's being modified by print message. Methods are a type of callable that's part of an object. This is something that you've probably encountered. Maybe you've written some of this so far in your Python career, maybe not, depending on what kind of programming you've been doing. But here's an example. Very simple. There is a class zoo, and on the class there are two methods, two functions. You can see the def keyword, so there's two functions. One is a special method under init, and that is called whenever this class is instantiated. It initializes the function. It sets initial values on it. So in our under init, we pass in a list of animals, and then it sets the instance variable self.animals equals to animals. Now, what's an instance variable? Whenever you instantiate a class, it kind of looks like calling the class, and then it creates an instance. Think of the class as a blueprint and the instance as actually building something from that blueprint. So when you instantiate zoo, it allocates in memory all the memory for a zoo object, and it calls under init, and it sets in parts of that object, it sets these instance variables. So self.animals is the instance variable. There's memory allocated for it, and it stores the animals that you passed into that memory location. Then that instance variable, those instance variables can be referenced elsewhere inside of your class by looking on the self object that's passed in. And you can see that in the second method, def get number of animals, self. So self is always going to be this first argument to a method, and it is automatically added by Python, and it is the instance of the class that the method was called on. And then these methods can reference these instance variables. They're called attributes when they are attributes of a class. It can reference it from another method. So we set animals in the under init, but we're making use of it in get number of animals by returning the length of that animals list. So here's just an example of making use of the zoo class. Z equals zoos with zebra elephant as a list being passed in. So this is where I'm instantiating the zoo object. I'm taking the zoo blueprint, and I'm creating an actual instance that has memory allocated to it. And then z.get number of animals returns 2. And the reason is because get number of animals consults the list that got saved. It says how many elements are in it. There are 2. So just a very, very, very fast overview of functions, procedures, and methods. Let's start getting into some things that you may have seen, you may not have seen. Functions can be assigned to variables. So here I'm programming. I'm using a library. Inside of that library, there's this function called badly named. And it takes a message as a string, and it prints that out to the screen. It's a pretty simple function, but I have trouble remembering what it's called because it's badly named. I can't remember that what it does is prints a message to the screen. So I just take a variable, print message, I set it equal to badly named, and all of a sudden, I'm able to call print message as a function. Because what that variable holds is a function. So when I go print message parentheses test in parentheses, under the hood it calls badly named. It passes test as the message, and then badly named will print test out to the screen. So we can do this because functions are just another type of object in Python, and a variable can be assigned an object, and so that's all we're doing here. If you have a very, very short function, like our previous function, it's really the body of the function is just a single expression. Then you can use the Lambda keyword to set the function. So here, instead of saying def, print, def, badly named, so on and so forth, message, print message, we just say Lambda message, print message. And this maps really, right back to the def statements. It's exactly like doing the def, it's just shorter. So when you have something very, very simple, it could be clearer to write it like this. Lambda is a keyword, message is the parameters that you're passing in, and then print message is the single expression that makes up this function. You can't get away with trying to put multiple expressions in there, like with the colon, the semicolon or anything. It has to be a single expression, and that's it. If the expression returns some value, then that will be the return value of the lambda. If it doesn't return a value, like print message returns none, then none is going to be the return value. But it acts just the same as our previous example. When we call print message test, it's going to print test out. Why might you want to use lambdas? Lambdas can be useful, like I say, if you have something really short. So here's an example. We're going to create a dispatcher. It's an actions dictionary, and we're going to parse user input, and they're going to give us a command. And right now we know two commands. We know output and add. And then depending on which command they gave us, we're going to process the rest of the input and pass it to a function which is going to do something with it, right? So the user types in output space test. Our parser runs. It says, okay, two things here, output and test. It looks in the actions dictionary and says, what's the value for output? Oh, it's this function, this lambda message print message. Okay, call that with test as the argument. The lambda runs and it prints out test. Second thing gets parsed and the computer says, okay, I parsed out add 1 and 2. Okay, consult the actions dictionary for add. Okay, here's the function associated with it. Call that function with 1 and 2 passed in, and then it'll get back 3. So this is an example of where you might use lambdas. Remember though, lambdas are very, very succinct. They're very, very short. They can make your code easier to read if you're just dealing with some short, really, obvious code. But if you find yourself saying, oh, this lambda is getting longer and longer, or I'm struggling to fit this into a single expression, probably you want to write a regular function to do it instead, because it's going to become unreadable if you try and cram too much into a single line. Let's look at partial next. Partial can be used for many things. In this case, I'm going to use it for specializing a function. And what do I mean by that? Well, here I have a kind of generic function, division with remainder. It can take any dividend, any divisor, and it will attempt to divide them, and it will return the whole number portion, the quotient, and then whatever was left over the dividend after doing that, the remainder. So let's say you have 1 and 2 as the dividend and the divisor. How many times does 2 go into 1? This is 0 times. The whole number portion of this division is going to be 0. And then the remainder, well, there's 1 left over. I wasn't able to deal with that, so it's going to be 0, 1 is what's going to be returned. All right, that's fine. This is, like I say, a little bit generic. And in my code, I never have to deal with dividing by 2 or 3 or 4 or 5 or whatever. Every single time I'm using this function, I'm going to divide by 10. So I can use partial to specialize the function. Instead of having a division with remainder that can take any divisor, I'm going to name a variable divide by 10. And I'm going to use partial to specialize this function to only do division by 10. The way I do it, I pass it the function name, division with remainder, and then I pass it as a keyword argument to partial, the function, the parameter name of the division with remainder function, along with the value that I'm setting it to. Partial can take positional arguments. So if I was trying to set dividend, I could just pass in, the number 10 without using dividend equals 10. But because it's the second argument that I'm trying to hard code here, I need to use keyword arguments. And in Python, even though dividend and divisor are positional, I can also reference it as a keyword if I want to. So partial, division with remainder, the function name, divisor, the parameter name, equals 10, the value that I'm hard coding. Now, when I call divide by 10, 15, Python will say, okay, well, this is a partial function. Division with remainder takes 2 arguments. You're giving me the first argument, so dividend equals 15. And I have the second argument, divisor hard coded. It's 10. So now it's going to run through and do that division. What's the whole number portion? 1. What's the remainder? 5. I'll get the tuple 1, 5 back. So that's partial. That's using it for specializing a function, making it so that it's going to apply, certain hard-coded values to some of the function's parameters. You can also use partial to change defaults. So here I have a method, a function called from bytes. It takes a byte string as a message, and then it uses an encoding to encode that into text, which is in Python, you separate byte strings, which are, something a computer will understand, into text, something that a human will read. And it's going to use the ASCII encoding by default, meaning if I don't specify the encoding, it will use ASCII to try and decode the message from bytes into text. And then if it encounters an error, a byte that it doesn't understand, it will use the strict error handler, which means that it will raise an error when it does this decoding. So this is all fine and dandy, but in my code, I'm dealing with UTF-8 strings almost everywhere. And here, I'm calling from bytes. I'm passing it in a byte string, Toshio, and then my last name encoded as UTF-8. And I'm going to get a Unicode decode error back because the encoding by default is ASCII. I have to specify UTF-8 if I want it to work. Well, like I say, I'm using UTF-8 everywhere in my code. So I don't want to specify UTF-8 on every single call to from bytes. What I can do is I can use partial to change the default values. So here I'm going to say from UTF-8 is a variable equals partial. From bytes is the function that partial is going to use. And the parameters I'm going to override are encoding. Set that to UTF-8. Errors equals the surrogate escape error handler. Now when I call from UTF-8, under the hood it's calling from bytes. It's using this message string, this byte string that I'm passing in, but the encoding is going to be UTF-8 and the errors are going to equal surrogate escape. So it will do message decode and it will decode that as UTF-8 and I will get back my name, Toshio, and then Kuratomi in the Japanese alphabet. So that's a way to change default values using partial. Let's get back to the title of this talk, callables. What are we thinking of when we talk about callables? Well, all of the things that we've talked about so far are callables. They're variations on a theme. Objects can also act like functions. And this is something that Python adds. You can use this technique to add state to functions, which can be very useful sometimes. Let's take another look at our byte decoding. Instead of using partial, we could write a class, a byte decoder function class. And we're going to add state to the function to set the encoding and the errors. How do we do that? Well, we're going to create two special methods. Under init, we saw before, it means that, okay, when I make an instance of this byte decoder function class, it's going to take two parameters, encoding and errors, and it's going to save those as instance variables, self.encoding equals encoding, self.errors equals errors. Okay. And then, if you look down below, from UTF-8 equals byte decoder function, encoding equals UTF-8, errors equals surrogate escape. Okay, that's instantiating a class. It's setting the instance variables. I see that. Now, when I call from UTF-8 as a function, what happens? Well, Python says, oh, you're calling this object, this instance of an object as a function. I'm going to look for an under call method on that instance. And it's going to find it because I've defined one. And it's going to say, okay, I'm going to treat this as another callable. I'm going to invoke under call. I'm going to pass it the parameter that you gave it. In this case, I'm giving it the byte string Toshio and then the UTF-8 encoding of my last name. And then I'm going to take that byte string. I'm going to call its decode method. And I'm going to pass in the encoding that was set in under init and the errors that was set in under init. So this is state, right? When I created the instance of this function, this callable, I gave it some state. I gave it encoding and errors, and those are our state that's going with this function. And then when I call it, it's able to consult that state and say, okay, I have encoding and errors from earlier. I'm going to use them to do my job. So let's apply the things that we've learned and try and fix a code smell. This will be the last thing that we do today. It's just kind of to see how you might use this in action. So here's some code. When you look at it, you might notice that there are some things that are a little fishy, some things you've not seen before, and you might wonder why they're happening. So I'll take you through what I see when I look at this. I see that, okay, I'm calling get all data. I'm passing in this normalized value, and then I'm setting an instance variable variable self.normalize equals to normalize. This is a little fishy. Normally, we try and set our instance variables in an under init, and we don't normally set them anywhere else. And I'll get to why that might be a bad idea later. And then I'm saying, well, where is this being used? And I'm seeing it's not being used in getAllData. Oh, it's being used in getNextRecord. So I set it in getAllData, and then it's being used in getNextRecord. And I see that getNextRecord is being called from getAllData. Okay, so it's kind of initializing the value there. Then I look and I see self.token is kind of doing the same thing. The only difference is that self.token is being set from the environment variable os.environToken, not being passed into the getAllData function. Okay, so I kind of have an idea now what the user was trying to do, the programmer was trying to do, and why I think this is a bad thing. So the programmer thought they were following don't repeat yourself. You may remember earlier we talked about that as, okay, if I take a function, and I pull this code out into a function, I don't have to write that function's code in line over and over again. I just call the function. That's a good use of don't repeat yourself. This is a bad use. The main reason is it violates the separation of concerns. The separation of concerns means that, okay, I have these two functions. They should know as little as possible about each other, and what they know should be formalized into their function parameters so that it is kind of like a contract between the two of them. When I pass in function parameters X and Y, then I will get back data that is based on X and Y. In this case, we're not doing that. We're violating that rule, and we are leaking information about the function's internal implementation to each other. So if you look, getAllData is setting self.normalize and self.token, and then it's calling getNextRecord. getAllData knows that in the implementation of getNextRecord, it is consulting self.token and self.normalize. This is not part of the contract that you're writing when you say a function parameter exists, token and normalize, and when I pass these in, it's going to affect how you run. Instead, you know, oh, if I set these instance variables, then getNextRecord will behave differently. But what happens if someone else comes along and modifies getNextRecord? Like maybe they cache the token. So after the first run, the same token is reused. All of a sudden, oh, I'm calling getAllData, and I think I have to pass a different token in the next time, set the environment variable to a different token next time. That will stop working because getNextRecord has changed its implementation. So this is a problem with violating the separation of concerns. You start to leak information, you start to depend on things that could change, and it makes your code more prone to bugs. It also means that your code is no longer safe for multi-threaded applications. So, typically as programmers, we think, okay, the code is going to go through, it's going to call things one at a time. It's only going to be doing one thing at a time. But in order to speed up code, you want to be able to make it run in parallel by using multiple threads. And so when you do that, all of a sudden you could have getAllData running twice because, okay, thread one you create a foo instance, an instance of foo, and then you start thread one and thread two, and both of them call getAllData, but one calls it with normalize equals true, and the other calls it with normalize equals false. The order that they're executing is indeterminate. The computer is going to execute things as fast as it can. Maybe sometimes all of thread one gets run before all of thread two gets run. Maybe sometimes part of thread one gets run, then part of thread two, and then part of thread one, and then thread two finishes, and then thread one finishes. When they get interleaved like that, thread one might say, okay, I'm calling getAllData. I'm going to set self.normalize equals to true. And then before it calls getNextRecord, thread two comes along and says, okay, I'm calling getAllData. I'm setting self.normalize equal to false. Suddenly, thread one is running getNextRecord, and self.normalize is set to the wrong value for thread one. So this is a problem when you violate this rule, when you start setting instance variables in order to pass data around instead of using function parameters. You can get your code in such a state that when it's run multi-threaded, it will have bugs. Okay, so let's talk about two ways to fix this really quickly. First way, I'm going to take and create an under init, And I'm going to still set the self.token instance variable, but I'm going to set it in under init equals OS environment token, just like before. Okay, so what I'm doing here is I'm saying, okay, instead of setting this in get all data, which is problematic because in a multi-threaded environment, two things can do that, because it violates the separation of concerns, which means that the two functions get all data and get next record know too much about each other. By setting it in under init, I'm saying the class is responsible for setting this instance variable. Anytime you have an instance of a class, self.token will have been set. Get next record can depend upon that to do its thing. And then normalize, I'm going to handle differently. Normalize was passed into get all data. And then I'm now going to say, okay, well, get next record is also going to take normalize, and I will just pass that as a regular function parameter in there. This way, if the user calls get all data with normalize, it will work. If they call get next record with normalize, that will work because normalize is being set when you call the function. So this is one way to fix it. Here's a second way. The programmer whose work I was modifying said, hey, I hate passing normalize every time too. Can you figure out a way to do it so that I don't have to pass normalize either? So here's how I do that. I'm going to create, a callable class, a get next record function. And you can see, okay, under init for this next record function class, I'm going to pass in normalize. I'm going to set self.token equal to OS environment token, self.normalize to the normalize that was passed in. This is state for the function. And then I'll implement under call. If you look at it, it is exactly the same body as we had before up here with get next record. It's just moved into this callable class. And what this means is, okay, now I've taken that method and I've abstracted it into a class, which can save some state. Now when I call get all data, I will create that function. Get next record is a variable containing a function. It's an instance of the get next record function class. And I've passed in the normalize that I was given when get all data was called. So now I have a function which has been initialized with these values. Every time I call that function in this code, data equals get next record, data equals merge data, data get next record, it is using those variables that I passed in, that state that I passed in, to do its job. So that's just an idea of what you can do with the callables that I've shown you. Go have fun with these. Go and try them at home. See what problems you can apply them to. And that is it for my talk. Any questions?
Thank you, Dosho. That was a nice presentation. I would have maybe a note on Lambda. Just my personal feeling about it, that and you kind of mentioned that if you try to cram too much into one statement, it can get difficult to parse and figure out what the statement is trying to do. So yeah, I found that avoiding Lambda is easier for me. And yeah, because sometimes I see a line of code with Lambda passed to filter, passed to map, and then it's like huge, maybe multi-line statement, from which my head explodes before I figure out what it's supposed to be doing. Yeah, so that's just, yeah, I try to rather split that into functions, but you showed us simple examples, and in those it makes sense to use Lambda.
Yep. Yeah, I agree with you. A lot of times when I see Lambda being used, it's someone who just says, "Oh, I want to be crazy and I want to stick everything that I can onto a single line," and it's just bad because then they can write it, but no one can read it later on. And becomes impossible to debug it.
Yeah. Ideally without a comment, and and later on even themselves can't figure out what it's doing. Yeah.
Well, thanks. This is really great. I'm actually working on a really similar function to the last example that you showed, or a program, I guess, where it's pulling data from a REST service and then sticking it into a database and that sort of thing. So this has really been very useful for me.
Cool. Glad it was helpful.
Maybe one question about the partial feature. If I understood it correctly, well, if I am to do what you did with partial, well, in the simple example, it saved me basically one line of code, because because I didn't know this partial feature. So if I would be doing something like that without partial, I would just define a new function, and in the function I would call the other function with some parameter. So yeah, but I guess that was the simple example, and then it can get useful with something more complex, I guess.
Yeah. So what I have found is that when I write a new function, I think I could write a new function that just calls the function that I intend to every single time instead of partial. But then I have to think about, well, how am I going to express the function parameters, right? So let's say I'm taking subprocess.popen, which takes 15 to 20 function parameters, and I'm saying, oh, I want to change 3 of these parameters to be hard-coded as certain values. If I write my own function that wraps it, then I have to say, what am I going to do with the other 15 parameters? And I might use, star args, star keyword args, but then I have to write parsing code to say, oh, I have to pull I have to look in the keyword args to see if this certain parameter exists. And technically, I should look in the positional args too and see if it also exists there. And then I pass those into subprocess.popen and so forth. So I'm having to write all this boilerplate to do it robustly. But if I use partial, then the implementation of partial takes care of all that for me, and I don't have to worry about it.
Yeah, that's a good point. Okay, thank you.
All right. If there's no other questions, then I guess this is the end. Thanks for coming, everyone. We'll try and have these once a month at least, and we'll let you know what other ones are going to come up next.
All right.
Thank
Thanks a
you.
lot.
See you next time.
Thank you.